Okay, we are at 1 minute to start the class. And well, you're watching over there kind of the um, what we will study today. I mean, kind of the content we will try to explore today. And I will share you a little watching over there. I think you always will be like checking this platform and checking the assignments. Okay. And I think that we will do a little change with the forums. Okay. The activity will be working. We'll stay working during all the weekend, but it ends on Monday. Okay, because this is an evaluation I have to make very quickly. And so sorry, I don't know why you cannot see the evaluation of the forum. Don't know if you can see it. I would hope that yes, but it's already evaluated. I think many people here got the 10 points of this one. Remember that it are 10 points, right? But then we're gonna change this evaluation. Okay, so let's see. Two more students.
Good morning.
Good morning, good morning. Okay, then
Good
I'm gonna check
morning.
the assistants. Good morning. Then I'm gonna check the assistants. So, like I was saying, here we have these weekend activities. In this first part, this first block of the class, remember that we have like these first 4 hours. We will try to focus into the introduction to algebra. It is a connection of what we saw, I mean, the arithmetics and the algebra. We will try to work the ratios and proportions, study the proportionals rules, which are the direct and the inverse, and see these in some problems, some story problems, which at the end are like the things we want to study. Okay, I mean story problems, because problem solving is the base of this course, is the base of the teaching mathematics today, and we'll stay like that until we, I don't know, move to something else, to something new. But this is what we want to study today in this first part. I mean, in the morning, and he's missing the other part. Sorry, I didn't talk about the sequences. Have you ever heard about sequences, mathematical sequences before? No, but I think that many time ago, for example, Banks works with the geometric sequence in order to calculate the um, amount of interest the people will pay, for example. Today we have and use other kind of formulas that summarize this pretty good, but time ago it was one of the mathematics that was useful. Okay, a lot, especially when you ask for a loan, or if you have to pay some money to the bank, you will get the calculus based on those geometric sequences. Of course, the years changes, and I think that everything is going to evolve and becomes better, right? It's like the main idea. But we should know about this ones because at the end they help us to connect the arithmetic with the algebra, which is at the end the second area we want to study, and we will study this one or start study this one today and continue the next weekend. Because remember, today in the afternoon, the second part of the class will be to work or to listen the groups and see how's everything going with the project. Okay, if you already start, if you already have the book, if you already are start listing the topics, if you already like separate the blocks, or you will work in a different way, you will decide to do this. Of course, some recommendations, some observations. If you already have an advance of the job, it will be so good to see it. So these are the topics we will start studying, and we're the main part of this one again is like see how can we connect the arithmetic we studied at the beginning, the last weekend, with the algebra. We will continue or start, I mean, to starting today. I'm saying continue because it's something you already know. When I ask you about algebra, what activities do we have for today? The assignment number 4, the assignment number 5, which is not already here. Okay, it's not already here. I will upload this in the afternoon. I hope so. Just depending of how do we go with the topic. And then the activity, which is the photo number two, it's already here. Okay, just that it will be different. The photo number two will work like a Padlet, like the first activity you did. Okay, so you will participate in a Padlet, try to do two participations, and it will be for this weekend, right? I mean, it's an activity that we start today, you have tomorrow to participate, you have last day to participate until Monday, two participations. Okay. And what about the afternoon? Well, as you were asking in the WhatsApp group the last time, I mean yesterday, this is the schedule we're gonna be following: Group One, Group Two, Group Three, Group Four, and I hope to see you there. Right? I mean, it's a teamwork. This one. Remember that this project is 30 points, and I will start evaluating this one today. Okay? Because I mean, you must like let me know what's the advance you have or the questions you have, everything, to start working on it. Stephanie.
Like in this part that, where we're going to meet with the groups, it's with the same link.
Yeah, is with this link
And
and
we meet with you. For example, we are group one from 1 to 140, and then we work on the assignments. We don't have to
no,
connect
you
it.
don't have to stay. No, you don't have to stay. That's what I want to tell you, right? Because it's the same link and everybody have access to this one. I will ask you to respect the schedule, okay? If it's group one from 1 to 140, so just with group one, then I will have time for the other groups. What can you do in those hours or those minutes that you will not stay connect? Well, you can work in the assignments and you can make questions even about that in the at the moment of the meeting. But we're gonna give priority to the project. How's it going? If you already start matching the contents, at the end, it's not complicated the project, but require that you work on it. I don't know if you already invest some minutes on this one or some time on this one. I mean, because then we're gonna have many things to do during the weekend. And just to start, because I'm almost done here, as you can see here, we have the two activities. The photo number two, which in this case will be it will not be a photo here in the platform because I don't know. Last time I have a problem checking it, so it will be a Padlet. A Padlet's much easier to do it. That's why this assignment works like a homework. They receive a name. These ones, those are like the same, but you don't have to upload anything here, right? Just like write the, or if you want it, I think you can upload a screenshot of your participation, right? That's something you may do. Honestly, I will evaluate everything in the Padlet, and then I will translate the information or your score over here. Okay, so we are in the second or starting the second block of the or the second unit of the class, and I'm talking about the algebra. That's why today we will start learning or listening something about this one. I can say that it's that you will learn. I mean, you learned those things time ago, just that maybe you don't remember it so good. But it's so important that we keep in mind those. Just a little question. Let's start over there. Okay, Ana Maria, you have a question?
Yes, I have a question. You can hear me?
Yes, yes, yes.
Okay, good. So then I have a question. Last weekend I was looking for the videos of the class and it was showing me like an error. So I don't know if maybe you can double check or you can show me where we find it because I was having problems to find those videos.
Okay, let me see. For example, here is
Me
the
too.
first meeting link, this one. Then here I have the other link of the meeting. Well, I'm gonna access to this one right now just to see if you have any trouble. As you can see, oh, here, I estoy yo. 1 hour 49, so it's the complete first part of the class we had the last time, just because it's longer, right? There he is. Don't know if you're watching it. Are you?
Yes, yes, we
Okay,
are
it's,
watching.
it's loading.
Okay, let
But
me check then.
Mister,
hello?
can I share my screen so that you see because it's the same thing that happens to me when I try to open it. It
Uh-huh.
says like error, forbidden, something like that.
Okay. Well, I don't get it over there. Well, I will upload those to YouTube. I think will be better. The last time I saw it, and no problem. I made a double check every time. I don't know what happened. So I will try to see this again, okay? The advantage is that we have the class in the Jamboard too, okay? So you have your notes over there, you have like your ideas, your questions, and a good reference of how the class was with that Jamboard because we made an activity over there. So that's why we have like the two tools, right? Okay, so I don't know what happened over there, but the link is over there and it's open for everybody.
I sent an image to the WhatsApp group for you to see what is showing
What's
me.
happening with yours?
Uh-huh.
Okay, let's see. Okay, I honestly don't know what happens over there. But don't worry, what I will do is that I will upload those to YouTube, and I think we'll not have this trouble. Okay, so I think now
Thank
we
you.
can start.
Okay, thank you.
Thanks to you for telling me. Okay, and every time something like that happen, I will appreciate if you tell me this in the WhatsApp group, and I will try to look for the way to help you as quickly as I can.
And the forum, I check when you go to grades, it is already evaluated. It is already the grade there.
Okay, thank you, thank you. Because I was checking over there last time and it doesn't appear anything.
Yes,
It's just-
but if you go like to the forum, it doesn't appear anything there. But if you go to grades, then it
grades?
is yes.
But
Yes,
in
I
my
think
case, I
grade-
don't see it. That's the problem.
Okay.
Yes, I know that I evaluated, but I don't see what I evaluate in the grades. What a problem!
Okay.
I don't know. But don't worry about it. I mean, it's something that happened with this platform. It's just that we have to get used to work with this one. And well, I wanted you like start thinking one little question. What is algebra? Since I checked the assistants, because I don't know if everybody's here. Let me see. Danela, is Danela here? No? Then we go with Lexi. Is Lexi here?
Yes, yes.
Okay, now we go with Mercedes. It's right there.
Hi, we're here.
Or Nandi. Is Nandi here? Nandi Naomi. Okay, Andrea Nicole Miller.
Here. Good morning.
Good. Cynthia Valesca Aguilar. Oh, there you are too.
Here. Good morning.
Morning. Now we go with Tracy Rochelle.
Good morning, present.
Okay, Milagro Carolina.
Here, aquí estoy.
Okay, and Lindsay Paola. Sorry,
Present.
Listening. I'm sorry, listening. Listening, Paola.
Yes,
There you are.
yes.
Okay, then the rest of you are here because I was checking when you were connecting. So this is morning. Yeah, that's what I'm saying. Because when you were connecting, I was checking. So don't worry. I just don't have an idea if Danela is connect. Is Nandi?
Hello?
Is
Did
Danela
you
connect?
say Ana Maria? Or
No.
is that I didn't understand, sorry.
No. I'm asking for Danela. The ones that are not connecting right now is Danela, Nandi, Naomi, and just those ladies. Okay. Then the rest of you are here in the meeting. So good. Okay, now I think we are ready to start. I will ask you to answer a little question right now. Okay, just a little discussion, just a little idea of what I want like to hear. And can you tell me something about the algebra? Do you know something about algebra? What do you know?
It's a branch of mathematics dealing with symbols and functions, more or less.
Okay, you say
Graphics?
something. Graphics, you say?
Mhm.
Okay. What else do we know about algebra?
We use letters and numbers?
Okay, exactly that. At the end, algebra is like the connection or the generalization of the world of the mathematics. Because in mathematics, we don't just work with numbers. We work with letters. Remember at the end, I told you like what is the formula for mathematics, which is an addition of postulates, properties, theorems, numbers and letters, which at the end makes that tool that help us to measure the world. Of course, mathematics goes away to that idea, and it's much higher. I mean, it's much bigger. The definition of mathematics is so huge, but we can like focus in the main idea, which is a tool to measure the world, because at the end, many of the other areas are related with this. Okay, we should focus in this first part, so paying attention, because here we go with our first topic of today. As I told you, the topic of proportions and the direct and the inverse variation. That's what we want to study today. What do we have as an objective? Determine the value of a proportion given a complete ratio and a no value of another one. Have you ever used the rule of three before? Have you ever used rule of three? Does it sound familiar to you? The rule of three? No?
Yes.
Yes. When this one is useful?
Well, I have used it when my students, for example, didn't make a quiz and we need to have this grade with an exam.
Exactly.
So we use they helped me to make the rule of three because, yeah, but yes, I have used it.
You have used it. For example, suppose your test is 30 points. I think it's like 35 points, or I don't know how do you evaluate in the work. But suppose your test is 30 points. But students couldn't present an activity which is 20 points. How can you evaluate something of 20 points with 30 points? Is it possible? Well, yes, that's what the rule of three do. Help us to understand what proportion of that 30% you have and make that proportion works in the 20%. Essentially, that's the rule of three. This is something like kind of the activities we will do, okay, in 10. And then what other objective do we have over here? It's determine the type of proportion we will make. We have two kind of proportions you will see. So I hope you get it. And the class will be very easy, I think. It's not complicated. That part of the proportions is pretty easy. So what is a proportion? Let's start over there. A proportions practically will require a simple idea, and it's a kind of comparison, but let's hear or see those different definitions or vocabulary we need to know before we go to the exact definition of proportion. First of all, we want to know what is a ratio, what are equivalent fractions, what are essentially, well, the same part of the proportions, how to work the cross product property, which is the famous rule of three, and how to work the direct product property, which is essentially the inverse proportion. And here we may see the two kind of proportions we know. Question to you, do you know what's a ratio? Do you know what's a ratio? No? And it's because we normally have work with ratios every time. Ratios are quantities that we compare, okay? For example, the amount of sugar spoons you need to prepare one cake. I don't know. Or the amount of water you drink per day. Or if you like to do exercise, like the amount of kilometers or meters you can run in 1 minute. Those are ratios. When you are in a car and you can see the speed of your car, what is this one? A ratio, because it's a simple comparison of two amounts. One of the ratios we normally know is that one, velocity, which is the one that compares the amount of distance by the amount of time that maybe you pass or you go in a traveling, for example. Okay, so those are little things that count and matter at the moment to talk about ratios. It's clear the idea of ratio. simple comparison of two numbers. I think you can create ratios of something you have been living. I don't know. Can you tell me one? Because like I say, it's something we normally do every day, just that we don't focus and see it like a ratio. We just do it. Eunice?
For example, when you're making coffee, you make a ratio of how many spoons of coffee you need for an amount of water.
Okay, excellent. If you have 2 liters of water, how many coffee spoons do you think?
2 liters. It depends on how strong you like it.
Okay. Okay, so there you go. But essentially, it's like that because you compare one amount with another amount. Okay, I don't know, maybe 10 spoon of coffee will be good for this one.
Or for example, when we're making baleadas, like
Uh-huh.
3 cups of flour and 2 spoons of let's say
No,
baking soda or sugar, something
exactly,
like that. Yeah,
exactly
and
like
a
that.
quarter of oil, something like that.
Exactly that. So you're comparing quantities, you're comparing amounts. So ratios are things that we use in daily life, just that we don't see it like ratios, but we use them. Okay, equivalent fractions. What about equivalent fractions? Equivalent fractions related with two fractions that maybe don't look like they are the same, but essentially represent the same. As an example here, we have 2/6, which is this part, but this part's equivalent to that one, which is 3/9. They represent the same. They don't look like they are the same, but they represent the same. Suppose you have one of those pizzas of Little Caesar, which are like 8 pieces. And suppose you have another pizza with the same size as that one, but you cut it in 12 pieces. Maybe the pieces are not the same size. As we can see here, this part that is 1/6 and this part that is 1/9. They don't have the same size. But together, mixing some of those, we can make the part of the pizza being the same size. So when we talk about equivalent fractions, we're talking about these kind of expressions. Okay, let's go and talk about the main important definition, which is talk about the proportion. When we talk about proportions, is a simple comparison of ratios. Simple like that, a comparison of ratios. And then what do we do, or what do we use to solve proportions? We will use one of those properties, the cross product property, the famous rule of three, or the direct product property, which is the inverse proportion property that we will study. Okay, so let's see and start with this ones. As I say, a ratio is a simple comparison of those numbers, of those quantities, but in this case, you can create some of those with sense. For example, compare the amount of gasoline your vehicle require per kilometer. As you can see here, 55 liters is to 700 kilometers, and this is the way to read it, right? That's the way to read it. Normally, they can be written like A is to B, and there is a condition that is that B cannot be zero because we create a kind of fractions. At the end, this is like a fraction or behave like a fraction. And that's why we need to understand that our equivalent fractions sometimes, because we can represent one ratio in different ways. For example, what means 20 kilometers in 2 hours? Is an speed. But is there a simple way we can understand this one? 20 kilometers in 2 hours. Is there a simpler way we can understand 20 kilometers in 2 hours? What do you think? Or not? I mean, you have a fraction over there and you simplify it. That's the question essentially. Can we see it in a simpler way? What do you think?
That you go 10 kilometers per hour.
Exactly like that. And this is another ratio equivalent to the one we have right now. They don't look like they are the same. I mean, 10 kilometers is lesser than 20. 1 hour is lesser than 2 hours. But essentially, both are representing the same. So what is the ratio that is involving here? Is this one, okay? Normally, we call those like unit rate, but don't worry about it. I mean, we can understand a ratio even if it's divided by 3, 10 divided by 3, or 10 divided by 4. No matter. What matters is that you may always focus that this is not the only way to write it. For example, then I can say 40 kilometers in 4 hours, and I'm talking about the same ratio. Don't know if you see that it's exactly the same. So no matter, excuse me? Okay, I think your microphone activate. So there you go. Essentially, it's like that. And when we talk about ratios, we're talking about this. Is it clear, the idea of ratio, that simple comparison of two amounts? Of course, you can do it with baleadas and what else, coffee you were saying. You can do it with whatever you want. And at the end, we will see with what can we do it too, okay? When we talk about these equivalent fractions, as you can see here, I have another example of what I did in the other one. And those are fractions that may have different numerators and different denominators, but they represent exactly the same value. Remember that fractions are rational numbers that can be written like we see it. Stephanie, do you have a question?
Nick, so ratios, it's like a fraction that can be simplified and also gives up the same result, kind of.
Not necessarily that can be simplified, right? Not necessarily that can be simplified. For example, right now you are 23 students and I'm just one teacher. Okay, so you're 23 over 1. It's not something that you can simplify. But maybe if we go and work with the same ratio for all the classes, then in 2 classes, I think we will have 46 students and 2 teachers if we respect the same ratio every time. Essentially, is like this.
Okay.
Okay, yeah, because not necessarily are amounts that always simplify. No. This was just a little example to show you this other idea, which is the equivalent fractions. So equivalent fractions practically are behaviors or are fractions whose behavior is like next one. If you see 55 over 700, both of those can be simplified because those numbers, if you see, have common divisors, right? What are the divisors of 55? Let's see it that way. I know with 700 it's a little bit complicated, but with the other one it's a little bit easier to see it. What are the divisors of 55?
11.
5.
And 5 and 1. Exactly. Those are the ones. I'm not going to include the 1. What about the divisors of 700? This has many divisors.
2,
10.
4, 5, and 7.
Okay, 2, 4,
5 and 7.
5, 7. I think it's missing one more.
It's not 10.
Yes, 10 can be working over here. What about 70? I mean, the list will be so huge. It doesn't have sense to continue the list, just that I want to show you something. They have a common divisor. I mean, both of those can be divided by the same number. What happened if I divide 55 by 5? What happened if I divide 700 by 5? Of course, I will get next result, which are showing me that those expressions are equivalent and maybe they don't look like the same. I mean, 55 is a big number. I mean, it's a greater number than 11. The same happens with 700. It's a greater number than 140. but at the end, both are representing the same amount. That's something that happened just in mathematics. In other areas, it's so hard to see that two things are equal even when they don't watch the same. Okay, it's something that happens in math. Is that idea clear? Okay, now we are clear with this one. We may go to the other one. Let's talk about proportion. It's exactly the comparison of two ratios. Okay, so we're going to see those ratios working like one. And we can see it in a simple way or in an algebraic way, like the equation of two ratios. And here we will see the famous rule of three, which is the one Miss Mercedes saying that needs some help to get it. I think you're gonna help now everybody to get it because it's so easy. So when we talk about proportions, we have different ways to show it. Normally, we will use this notation, which is the ratios comparison proportion notation, or just proportion notation. The other ones are a little bit like formal, more formal, but we don't teach students this. We don't normally teach the students this way, okay? Or the way we have to like mention it. What is the name? In this case, we can see, or we can read it like A is to B as C is to D, understanding that there is a relationship between those, and the same relationship between those is working for the other two amounts we are comparing. So essentially, we can say that proportions makes, or is when you make an equation of two ratios. To make it work, you must be sure that those ratios are behaving the same, or you may force the ratios behave the same. A little example. Suppose you are evaluating your test like 30%. But suppose one of your students couldn't go to classes or never present the homework, and the homework was like 20%, the problem I made at the beginning. If the students get like 15% or 15 out of 30 in the test, what will be his score in the homework? What do you think? Because this is essentially the rule of three, which is our next idea. How many points does he or she have depending this score? If let me know it, please. I think somebody raised the hand. No idea. Vamos a ver, lo ponemos en contexto. Un estudiante no, este es un problema inventado, algo posiblemente como lo que vio la compañera Mercedes. Si tenemos un estudiante que va a ser evaluado o que necesita evaluarse del 20 puntos, pero no pudo porque no sé, ustedes pueden poner el pretexto que quieran, de las tantas excusas que hemos escuchado. De esos 20 puntos que queremos ayudar al estudiante para que obtenga, dijimos iban a ser evaluados en base a lo que sacara en el examen. En el examen este estudiante solo sacó 15 puntos. ¿Cuánto tendría de 20 entonces? Esa es la pregunta.
La mitad.
Porque sacó la mitad en el examen, tendría la mitad de 20 puntos en su tarea. Bueno, usted utilizó proporciones ahorita, Ana María. That's the idea of proportion. 10 of 20 then, okay? Well, what happened if the score, instead of being 15, a number we normally see very quickly like the half, the student gets like 16. 16 out of 30, it's what out of 20? That's the question. So this is essentially a proportion. And what we do is like create or look for the way to find that unknown value. So we may create two ratios, one incomplete, one complete, to look for the way to find it, to force our exercise to behave in a situation we may use. And this is essentially the rule of three. So we will see it. Here comes one example about how this rule of three works. Then we will go with the other property. But right now, I want that we focus in this simple idea. So what is the amount of money you will pay to one object you want to buy that is 30% off? And the price of this object is 500 lempiras. So what will you do to solve it? How can you solve this amount? A simple situation, right? Very simple situation. Ideas to solve it?
Mm-hmm.
Okay,
500.
so
Sorry, sorry.
it's okay. Who goes?
Okay, I think
No,
you.
Okay,
you.
so
Okay.
basically what I do when I'm like getting the percentage of something, I would multiply 500 times 0.30, and that equals 150. So that's the amount I have to take away from 500 to know how much I have to pay.
Exactly. So this is one way. And why you multiply by 0.30? 0.30, you say?
Yes, because it's the
Why
percentage,
0.30?
because it's the percentage of 100.
Because it's the percent of 100. Well, essentially, question. What is 30% as ratio? Because at the end, 30% represents a ratio.
30 over 100.
30 over 100. Okay? An amount of 30 over 100. An amount of what? We don't know, but we just know that it represents a percent. Okay? Now, question to you. What is the total price of the object you want to buy?
500.
500. Do we know what is that 30% of this amount?
No, so we put 100, right?
Okay. So
Or
we don't
no.
know. We don't know it, right? This is essentially what you do, Eunice. But I mean, you do it in a way that I don't know, you have like a formula, I think so, which at the end, formulas comes from this. It's okay.
I just go like, let's say the total amount, I just multiply by 30 and then divide by 100, and that's easier.
Okay.
Yeah.
Yes. But I want that you see how the rule of three works, because essentially is what you're saying, but you're saying this like a formula. And rule of three doesn't work like a formula. It's a simple rule. The rule of compare those amounts. Okay, essentially we learned this like the cross product property too. This is another name that it received. Cross product property. And what the cross product property says that you compare two ratios, as I'm doing it right now, you can conclude the answer of this one, of this unknown that I have over there, multiplying those amounts in cross. Essentially, that's why it's called a cross product. So I'm agree with you in the way you're saying, because essentially is what we will do. We will multiply 30 times 500, and this will be equal to the product of 100 times that question mark. That question mark right now is representing the 30% of 500. Of course, you already told me how to do it in a quickly way, but not all the problems will be related with percentages. So we may solve this one, and essentially this 100, which is like doing a change to this question mark, which is my value, we'll need to pass to the other side. Do you know what are rules to translate values to the other side of the equation? I mean, do you know the rules of equations? If something is multiplying, I think you know what happened in the other side of the equation. Do you remember these things?
The process is going to be the opposite.
Excellent. It's going to be the opposite. It means that if here I'm multiplying and I want to move this 100 to the other side to exactly know what is the unknown value, so I will move it to the other side to divide. Essentially, this is how mathematics works. So you may work in your calculator or solve over there 30 times 500 divided by 100. It's essentially multiply 30 by 5, which is 150. What does it mean? It Means that 30% of 500 is 150. I think we were clear with the answer, but maybe not with how to get it in the proportion way. Because not every time we work with non-proportional things, we may work with proportional things. Okay, here it is. So what will be the price of the object if this is 30% off? So 150 lempiras less, which at the end makes 350 lempiras. Exactly like that. Okay, so here we have a simple situation that helps us to understand the relationship or the idea of proportion. And we already used one property, the cross product property, which helps us to solve ratios. Okay, ratios compare as equal amounts. I mean proportions. And essentially what we will see is this kind of exercise. Okay, so I will give you these properties later, but I think that right now with this exercise that you see, practically the operations you were saying are here. For example, Mrs. Cynthia, I think you say this one, 30 times 50 divided by 100, exactly the same. Maybe you can have 30 divided by 100, which is 0.30, multiplied by 500. It's exactly the same. So those are simple ways to understand the proportions. Okay. So here goes the other cross product property, and this one is the one we use, okay? And essentially is to create or to show that those amounts are exactly the same. I mean, right now, 555 and 700 doesn't look like 11 and 140. But using this property, we can show that those are exactly or hide exactly the same relationship. As you can see, they are products. Even if they don't watch, they are the same. I mean, 55 times 140 gives you this amount, that's 7,700, and 700 times 11 give you 7,700. So both of those amounts represent the same. That's like the main idea of the cross product property, and this is rule of three. This is the famous rule of three. In the example we have, I ask you to identify what would be the score of the student if he has or she has 16 out of 30. What will be out of 20? I don't know. How can I solve that? With 15 was easy because you find the equivalent fractions so good, base 20, right? Based on the 20. But right now, how can you do it? It will be a decimal answer, I think so. And the way to solve it, well, I think you can tell me what is it using the cross product property, just to see if you get it. So what will be the score we should place in that student score in homework, which are 20 points, if this student got 16 out of 30? Because not always is like a percent, right? But essentially is the same idea. What it will be? How many points do we have to give to the student? And I think it will be a decimal. So give me the decimal.
Yeah, 10.6.
Questions? Eunice, you gave the answer. Maria, you have a question?
Licenciado, disculpe. Solo que me estaba conectando y desconectando. No sé si pasó lista. Disculpe, no deja responder que iba, pero necesito... Bueno, por si me salgo a cada momento y pasa lista, aquí estoy siempre, porque estoy con datos y se me fue la energía. Disculpe.
Es María Daisy.
María Daisy Madrid Pérez.
María Daisy, muy bien, sí.
Ahorita me voy a mover a un centro, me voy a mover a un centro comercial para estar con la computadora por si hay que hacer algún trabajo.
Excelente, tranquila. Bueno, tranquila, muy bien.
Yo también, Nandi Naomi.
Nandi, ok, sí, estuvimos preguntando por usted ya ratitos.
Sí, es que yo no lo escuchaba bien, Lee. Ahí le escribí al chat de la videollamada.
Ok.
Sí, tenía problemas con el audio, pero ya lo arreglé.
Muy bien, perfecto, Nandi. So here we go, and yes, the answer will be like 10.6, like your classmate Eunice said. This is the score we should give to the student. Rounding this one, I think that will be the 11 or 10. Well, honestly, rounding is 11. And at the end, this is the way to use the famous rule of three, which is Not complicated, as you can see, Mercedes. Okay. What else do we have over here? Another rule, behaving a little bit like the cross product property, but this one works for other kind of proportions. The ones that I tell you at the beginning, the ones that work with the cross product property works for direct proportions. I will explain you what are direct proportions. Should write over there, direct proportions. And this one works with inverse proportions. Essentially, this is another way to understand that relationship that makes those numbers. And what we do is that we multiply the numbers of the fraction or the numbers of the ratios, and we compare those like the same. Essentially here, this is not the best notation for this kind of inverse proportion. The best notation for this one is this other one. But normally, because we will work proportions this way, we will see it like fractions. Just that they make an inverse proportion. I will teach you what is inverse or what is direct proportion, but this is what we want to see. In this one, if we try to use the cross product property, I mean, if we multiply 5 times 40, sorry, 5 times 40, I said. Five times 40. And if we check if this equals to 8 times 10, it will not work. 5 times 40 is 200. 80 times 10 is 800. They don't make that same relationship, okay? So we can say that they don't make a direct proportion. They should make an inverse proportion. And the way to compare an inverse proportion is not using the cross product property. It's using the direct product property. That's the name it receives. And what you will do is multiply those numbers of the first ratio with the number, and then the numbers of the other ratio, okay? Making a comparison of those products. 5 times 80 gives you 400. 10 times 40 gives you 400. And essentially, those amounts behave different. I don't know if you can see what is like the difference between them and the difference between these other ones we tried. Here we have a 5, and then here we have a number that is greater than 5. Here we have an 80, and then here we have a 40, which is lesser than 40. Here we have a 55, and then an 11, which is lesser. A 700 and 140, which is lesser. Don't know if you can see what is the difference between those amounts.
That the
Those
first
kind
one
of-
is, sorry, that the first one
Yes,
is like the bigger, and then the other one is like the smallest. And in here, both are the smallest, and both
Excellent.
are the bigger
Excellent.
ones.
Excellent. That's like the main idea. And it's like a change that happens. So what are the kind of proportions that I told you that we have? Because we have two kind of proportions at the end. This is what we want to study right now.
The direct and the inverse.
Excellent. Direct proportion. This one is a direct proportion. And this one is inverse proportion. Okay? Like Anna say, one's like growing and the other one is like falling down. Okay, essentially it's like this. So let's see what are those proportions that we can have. So proportions can behave in a direct way or in an inverse way. In the direct proportion, if the amounts grows, the other amounts will grow. Like the example we have, which was 55 over 700 equals to, well, it's not that just grows. If the amounts decay, the other one will decay. It's like this. For example, here we compare this one with 11. It means that this amount decays to 11. It means that this amount should decay the same way as the other one, 140. The other example we have over here, 5 over 80 equals 10 over 40, have something different. If you see 5 over 80, in this case, one quantity grows, so the other one must decay. That's why it's called inverse proportion. One grows, but the other one must decay or must be smaller. And as you can see, it's different. Here, both goes down. Here, one goes up and the other one goes down. Essentially, this is direct and inverse proportion, We will identify these reading some situations, so I will need your help, and I will need your analysis, and of course your participation, so try to raise your hand. In this case, we will try and explore the proportional conditions to identify direct and inverse proportion. Is it clear when is direct, when is inverse? I give you right now a simple example, but then you will analyze this in a situation, which at the end is what I want with this topic. Are you clear with direct and inverse proportions? You then go with the next part. Any questions about it? No? Okay. Let's see. Raise your hand if you want to participate. First problem. Here it is. Who wants to read it?
Can you back the screen because I want to make a screenshot, please?
Excuse me, Karen. Sorry, couldn't understand you.
Can you back the before screen because I want to make a screenshot?
This one.
Thank you, please. Thank you, mister.
Okay, welcome. So here's the first problem. Who wants to read it for everybody?
Me.
Okay, please read it.
Okay, so in the fruit store, the inventories follow some ratios. Like that? Yes, right.
Yes.
Because the fruits are sold in a box containing two kinds of fruits. You have 250 orange and need to ask for an amount of berries. If in the box you need to place 10 orange and 3 berries, how many berries you will need to buy?
So what this problem is about? Read it again yourself. There is one amount that maybe is not like giving us many ideas, but is this problem of direct or inverse proportion? You're comparing two amounts, as you can see. You're comparing two amounts, as you can see. I know if you're clear, what are the amounts that we are comparing? No idea? So we are comparing oranges with berries, right? That's what we're doing. We can create a proportion, well, a ratio of 10:3. But then I have a situation, and is that I have 250 oranges, and I need to ask an amount of berries, and a specific amount of berries, because then I will make those boxes to sell it. So how many berries do I need? It's the question. But question to you. We're going to answer this first, okay? Don't worry and answer the problem right now. Worry about the analysis of the problem. What kind of proportion do we work in here? Because we are comparing amounts. We are comparing ratios. What kind of proportion do you think we have here? Is it a direct proportion or inverse proportion? I mean, I have 10 oranges compared with 3 berries. Then I will have 250 oranges compared with more than 3 berries or less than 3 berries. That's the question. What do you think?
I think it's inverse.
It's inverse. Stephanie thinks is inverse. Okay, we're gonna write here inverse by Stephanie. So here's the data. 10:3 as 250 is to an unknown value. We may represent that one with a variable. I think we know that it is so simple. Here is the proportion. Question then, is it direct or inverse? So are you agree with Stephanie with this idea that is an inverse proportion? As the amount of oranges grow, then the amount of berries must decay, because that's the inverse proportion. One grow, but the other one decay. What do you think?
I think it's direct.
Me too. I think it's direct.
We think it's direct. We have Eunice and Marcela thinking it's direct. Because those things becomes interesting, I think so. Now, it's not a votation, right? It's not that we're gonna vote for which one do you think it is. No, it's one of those, and that's the advantage of mathematics than other areas. If I want to make those boxes with 10 and 3, 10 and 3, 10 and 3, 10 and 3, but I have 250 oranges. How many berries will I need to make it? I don't know if you understand the question, because we most focus over there. If you understand the question first. Well, let's see if you understand the problem. Do you understand the problem or not? Make your questions about it. We are looking for the amount of berries that we may need, we may use, if we have 250 oranges. We have a big amount of oranges, of course. And at the end, we want to organize them like every 10 oranges, I will need 3 berries. Eunice.
Okay, I think I got the answer, but I don't know how I got it. I think I might have done it a different way. Okay, the first thing, okay, I did well, you cannot see it, but I did the proportions. I placed 10 over 3 as to 250 as to x. And then I multiplied 250 times 3, and then I divided it by 10, and that equals 75. So for 10 oranges, wait, I need to buy 75 berries because I can make
groups of
wait.
3 groups of, you're right, you got it. I mean, essentially,
I can make 25 boxes with 10 oranges
exactly,
and 3 berries.
Exactly. We don't care about the amount of boxes. We just care about the amount of berries, but essentially it's like this. Okay, see it like that. I think this will help you a little bit better. If I have this ratio 10 is to 3, what happens if I have 20 oranges? How many berries will I need? How many berries will I need with 20 oranges?
6 berries.
6. Okay, if you see, if these amounts grow up, these amounts grow up. So then if I have 30, 10 more, I will need here 9, 3 more. So as you can see, this amount grows and this amount grows. Is this inverse or direct?
Direct.
Okay, I think we have clear right now. Stephanie, are we clear right now that is direct proportion?
Yes.
Okay, so you have to analyze it like that. Of course, Eunice already solved it, right? Then we're gonna solve the exercises. Like I say, focusing to identify if it's direct or inverse. It cannot be inverse because it's not that I have more oranges, then I will need less berries. No, if I have more oranges, I need more berries. That's like the idea. Let's see the problem number 2. Who wants to read it?
Can I read it?
Okay, please, Ms. Marcela.
One car makes 24 kilometers in 80 minutes in a straight road. How many kilometers will be the same car make in a straight road after 20 minutes?
What about that one? Is it direct or inverse? Is it direct or inverse?
Inverse, because you're reducing the time of the minutes.
Yes, inverse.
So does the amount of kilometers will grow in less minutes? That's what you're saying. That's what you're saying. Look, check how the information goes. That's the proportion. This is the information. So check it out. 24 kilometers in 80 minutes. So then in 20 minutes, which is lesser, you will cover more kilometers. If we're saying the same car is going over there, I mean, the same velocity will work over there, the same speed the car goes, it's working in the same straight road, in the same road, I mean. Does it have any sense? don't know. Tell me. Because I'm asking you, like, how many kilometers? I'm not saying that he complete the road, right? I don't know if that's like a confusing idea. I'm just saying that in a straight road, somebody in his car or in her car makes 24 kilometers in 80 minutes. How many kilometers will the same car make in a straight road after 20 minutes? Well, we can say that it's going same speed if you want it. Is it direct or inverse?
Direct.
It's direct. As I go with less amount of time, I will go lesser kilometers, okay? So it's a direct proportion. Of course, the situation will change, and honestly, this exercise is designed with this idea. The exercise will change if I say that he complete or the car completes the road in 20 minutes, but I will give you the amount of kilometers you have in the road, or just telling you about the road. But I will compare two things. Maybe minutes with speed. This will be the comparison in a situation like that one. Because lesser speed, more time. Much speed, less time, right? That's what happened in the road. Does it have any sense to see it in an inverse way? But in this case, it's a direct proportion, okay? Is it clear, the idea of direct proportion here and the inverse proportion here? Because this exercise could behave like the other one or can behave like the other one, but no, this one is of direct proportion. Somebody has a question? I think somebody wants to speak. I hear like a microphone over there. No? Okay. If we're clear with this exercise, I think we may go to the next one. What about this one? A painter needs 12 days to paint a building floor, a complete building floor. How many painters will you need to paint the next building floor with same characteristic of one and another? I mean, of the other one, of this one they already paint, but I need to do it in 6 days, okay? I have 5 painters that needs 12 days to paint a building floor. So how many painters will you need to paint another floor with same characteristics, exactly the same, but you need to do it in less time? So here's the data. What about the situation? Is it inverse or direct? Is it direct?
Inverse.
Okay, let's see. Let's hear the other ideas. Because Eunice have been answering the 3.
I think it's inverse too.
Okay. So who can tell me why? Who can tell me why? Why you think this is an inverse?
Can I say why?
Okay.
Because hang on. Because you are lowering the amount of days, but you are adding up to the painters. So one's going up and the other one's going down.
Exactly. I mean, it's not that and listen this, please. It's not that I need to do the job in the half of time, so I will need the half of the painters. Does it have any sense?
No.
No, right?
You need to double up the painters.
Exactly. I need to double up these people. O sea, sería una explotación bárbara si digo que a estas mismas 5 personas, bueno, menos de las 5 personas, que pinten en 6 días, si a 5 le tomó 12 días, no puedo decir que a 2 les va a tomar 6 días. Sería una locura, ¿no? Bueno, aquí en Honduras sí es así, pero bueno. At the end is about this. Analyze if it's inverse or direct proportion. And I'm agree with you. Yes, this is an inverse proportion exercise. Agree with you. Okay, now that we are clear with this analysis we did, we have here a conclusion of the type of proportions and maybe the formulas you may see related with this one. At the end, a direct proportion is a proportion where one quantity increased, so the other quantity increased in the same way, and vice versa. If one quantity decreased, the other one will decrease at the same way. In an inverse proportion, we have a quantity increasing, but the other quantity decreasing, and vice versa. Is one decrease, the other one must increase. So essentially, that is direct and inverse proportion. As you say, problem 1 and 2 are related with direct proportion, and the problem 3 is related with the inverse. So I think we need to use the rule to solve these exercises, okay? So here we have the problem number 1 about the fruits, about the amount of, not the amount of boxes, amount of berries we need to work with 250 oranges, like you say. Okay, so here's another way to make it. Understanding K like the comparison of, or like the ratio that we work in the exercise, we may focus in 10 oranges and 3 berries to complete that this K, which is a constant, and that's why it's called direct variation, because this vary or this change as the amount of things we have changes. I mean, in the same ratio. And the ratio that we work right now is K. This is another way to understand, this is another formula. So K normally will be that ratio that we discover, or the ratio given. Okay, in this case is 10:3. We can solve it creating the cross product property too, and conclude the same amount over here. You will see. Using this formula, we can say that if Y is the amount of oranges we need, X will be the amount of berries that we don't know. So we can solve it this way, but if this is too much complicated to you, because at the end here we conclude the same answer as Eunice did, we can create a proportion and use not direct variation rule, use direct proportion rule, or the rule of 3. Sorry, not direct proportion, the cross product property, I mean, which is the rule of 3. How? Comparing this amount with this unknown amount, sorry, it's not there, the X, because we know the amount of oranges, with this amount, which is 250 over X. How can we solve this one? Like we tried with the exercise of the object that you want to find the discount, which is multiplying cross, and essentially is what your classmate did. So here you're going to create 10x, or 10 times x equals to 3 times 250. Of course, the way to solve for x is use the opposite operation of multiplication in this case, because the 10 is multiplying the x. In the other side, we'll pass it to divide, and it's equivalent to this expression. Essentially is the same. We may see here as a division, but we may see here everything like a simple operation, 3 times 250, all that divided by 10. Any of the two ways you decide to work with will give you the same amount. Okay, this rule of the proportions of the direct variation, it's given by this kind of graph. Okay, this graph is the graph of a direct variation, and honestly it varies depending the value of K. But it's better to see it, I think so, like a proportion, as we did it over here. You don't need to do all that procedure, just make this one. You will conclude the same answer. Of course, we must be sure that this is a direct proportion, because if it's an inverse proportion and we do this, we're going to conclude something wrong. We're going to say that we need, for example, in the exercise of the painters, if we see it with the direct proportion, you will say that you need like 2.5 painters to make the job in 6 days, which is wrong. Okay, we will see it over there with the exercise, and this is the solution of the first one. Okay, we already solved this one. That's all good. What about the other one, the problem number 3? The problem number 3, it's about the inverse proportion. And the inverse proportion required that we focus in the amount that grows and the amount that decays. But in this case, we must focus in the amount that will decay. I think so. Okay, no, that will grow. I think so, because we have to create a proportion. As we saw it with the other one, we can create one rule, which is essentially kind of like the other one, just that here, instead of compare a division, we will compare a product. That's the difference between this ones. In one, you will keep the same division. In this one, you will keep the same multiplication. That is essentially, or the same product, not the same multiplication. That is essentially what we want to do. Solving this one in the making the proportion or using the inverse or the direct proportionality rule, we may have next. We may have 5 compared to 12, like the amount of painters that I will need compared with 6 days. If you see, this is the amount that goes down and this is the amount that will grow. Of course, I need more people painting to make the job in less time. So the rule here doesn't work like the cross product property, like I was saying. Okay, the cross product property here, the rule of 3 here doesn't have any sense. That's why we may use the other rule. At the end is an inverse proportion too. And I show you here like the 2 ways to make it, but honestly, these will be the best one. Multiplying those and multiplying those, we will create the equation that will help us to solve the exercise. X times 6. And the same idea, just that here we multiply in a different way. So here we have 5 times 12, which will give you 60, I think. So divided by 6, it will be equals to x. At the end, x is the same as 10. The answer of the exercise, that you will need 10 painters, as you can see. So these are the ways to solve this kind of exercises. And as we can see, we don't need many complicated things, or we don't need to do many complicated stuff to solve this one. Is this clear? Is the problem clear, or you have any question about it? As I solved one of direct, one of inverse to have an idea. My suggestion is, yeah, we need to formalize mathematics, but in the case of proportions, I think it's okay to do it by any of those ways. You're free to choose the way you like. So any questions about it? No? Okay, I want that we try some exercises of proportions, and I will move those to the Jamboard, okay, as a little practice. And we may work in the Jamboard. Just give me a second that I'm loading this Jamboard today. Just please try to not like erase something of the Jamboard. We'll appreciate if we take a lot of care not erasing anything, because the last time we had a little trouble. And of course, you may see something about the next topic too. So we're going to use this Jamboard for everything that we want to use today. There is the link. If you can connect, please, we'll appreciate. And I will move those problems over there in the first page. Yeah, right now you're watching something over there. Don't worry. In the first page, everybody in the first page. Yeah, do not go to page number 3. Stay in the first page. Is there where you will see this problem that I'm showing right now. And I think we're going to move to the Jamboard to solve those exercises. I will ask you first if it's direct or inverse proportion. That is the first thing we want to answer. That's the problem number 1, and we will see the problem number 2 over there too. Problem number 2 is next one. It's a little bit similar. Well, you will analyze as well this information, and you will conclude then if it's direct or inverse. So good that I'm watching many of you connect. The last class, yeah, you participate over here too. Remember that when you participate, write your name and your number list, because this is what matters at the end. like to evaluate your participation too. Of course, I have been evaluating the ones who have been like giving good approaches right now. That's so good. And let's see, here we are. I don't know, tell me, are you watching the Jamboard in the presentation? Yes, okay. And again, I'm watching some of you connect over here. Excellent. I have like 13 people connect. Let's start the first one. Let's start the problem of Carlos. Answer, is it direct or inverse?
We write it on the board, or we just say if it's direct or inverse?
You can write it over here. You can circle over here using that words that I already copied. You can circle it if you want it. It will be good. And then I think you can solve it. Or you can write it, no problem. Oh, there you go. So good. Remember that every participation you do, please leave your name. You can leave it with a post-it. Your name and your number list. Okay. There he is. It's a direct proportion, the problem of Carlos. Carlos earns $42 per 6 hours working in a call center. How much money will he make if he plans to work 10 hours in a day? More time, less paying? More time, less paying? What do you think? Excellent, Nicole. Excellent, Xiomara. I think we got it. Nice, Anna. Nice, Mercedes. That's so
More
good.
time,
That's
more
so good.
pay.
Exactly, more time, more paying, right? So it's direct
It's
proportion.
like when you work like extra hours or during the weekends or during holidays, you get double pay.
Exactly. So more pay, more job, more pay. That's what I wanted to say. Let's solve it now. Let's solve it. Let's create the proportion. Create the proportion. Here will be proportion. Let's create the proportion, because that's like one of the most important things right now. Create the proportion. Oh, you're writing over there. That's so good. But let's create the proportion. We're clear that it's a direct proportion. I think we understand the topic. And sometimes we do the extra, but the payment stays like the same, right?
It depends, you know.
That's the sad part sometimes. I don't understand those words. You wrote M to Daisy. Oh, Maria Daisy, I think so. That's what you want to write. Okay, you're solving it. You're creating your own rule and way to solve it. That's so good. Okay, I'm watching here. 42 times 10 or 42 times 6. That's the proportion. That's so good. Well, I think I will use the other one, the other page for the other problem, because I think you need more space over there with everything of or all your participations. Well, as you can see in this exercise, we have some space and we need the solution now. Agree with the proportion you are creating over here. Let's see. Xiomara, she says 46 is to 6, 42 is to 6. As x is to 10. You're right, that's a proportion. I think this is like the way to solve it, okay? This is like how to solve it. So I want to change something over there, and is that because we will use x like a variable, we may use these parentheses to show multiplication. I think will be so good. Excellent. Excellent, Marcela. You're doing the proportion. Somebody here is doing the process. That's so good. I think we have enough space. So that's so good. I like this one. So then we can 4 is to 80. Why 4 is? Oh, you're solving the other one. You're solving the other one. The other one moves to the page number 2, Marcela. If you wanted, you can move this one to the next page. because we want to solve here.
How can I move it?
I think you should like click on it, copy the information,
Okay.
and then open another text box in the other
Okay.
page and paste it.
Okay, thank you.
Welcome. Oh, here it is, 70 bucks. 70 bucks, the way to solve it. Let's create a proportion. 42 is to 6. As the amount of money we will receive that we don't know is to 10. I think here somebody was doing it so good, just that I couldn't see. But that's so good. You're trying it over there. Hey, careful with the problem. There he is. And what will be the way to solve it? I like that participation over here. It looks like a mess, but let me tell you that I enjoy that mess. So it will be 42 times 10 equals to 6 times x. Solving this one, we may have 42 times 10 divided by 6, and this is x. Essentially, x will be the result of this operation, is 7. So we may have $70 by working 10 hours in a day. Question to you. Now that we know if I work 10 hours, I will get a pay of $70. How much money will I receive if I work 1 hour? How much will I receive if I just work 1 hour? Because you know in the States, they tell you that a lot, right? Like the payment per hour. Cynthia, you were saying?
Yeah, repeat your question, please.
The question is, if we know that working 10 hours, I will receive $70, how much will I receive per hour, per 1 hour? In 1 hour of job?
$7.
$7, okay? No more, no less, $7. So essentially, this is the topic of ratios. You say that $7 per hour, okay, 2 hours, $14, okay, 10 hours, $70. There you have how this topic works. And this is how the rule of 3 works too. You got the rule of 3. Is the rule of 3 clear now? Let's see, Mercedes, I think, was the one saying that somebody helps me, she said. But I think now you're going to help people. It's rule of 3. It's so simple.
Yes.
Okay, thank you. And now I think we can go to the next problem. In next problem, again, no, there he is. In the next problem, I think you're working that one so good. For example, Eunice is saying that's an inverse. I don't know if somebody else can tell me if it's inverse or direct. Maria Daisy is trying to solve the exercise, but I don't know how can you solve, what method are you using to solve it? If it's the direct proportion or the inverse proportion. Read the exercise as well, careful, because this one, well, it's very clear. It takes 4 pipes, 80 minutes to fulfill a water container. If you need to fulfill a container in 20 minutes in less time, it says, it's how many, there's the letter T that doesn't go. It's how many. So how many pipes do you need? How many pipes? So first of all, is it direct or inverse? For example, Marcela is saying that is direct. Cynthia is saying that is inverse.
No, I'm reading it carefully again.
Okay. Okay. So Maria Daisy is saying that is direct. As the amount of pipes grows, the amount of minutes grows. Does it have any sense? Try to imagine this situation. 4 pipes fulfilling a water container. More pipes, more time. Less pipes, less time. I don't know.
Less time.
Excuse me?
Less pipes,
less time.
I don't get it, Cynthia. So sorry. Is that I hear you so far away. Can you repeat, Cynthia?
Less time, less pipes, right?
Less time, less pipes. Well, I don't know. I don't know. Eunice?
I finished, but I don't see it on your screen.
Okay. No, I don't know why.
But can I?
Oh,
Okay, I
there he
think
is. There he is. So what do you think about this? Why you say it's inverse, Eunice?
because we need more pipes to fill it up in less time. So I multiplied 80 times 4, that's 320. Then I divided it by the minutes that we need to fill it in. So that's 16 pipes so that we can fill it in 20 minutes.
In 20 minutes. Okay. As you can see, yes, it's an inverse. Because to do the job in a quickly way, you need more things working. Okay. Don't know if you see it. Now that we're clear that it's are we clear that it's an inverse? Because I'm still watching over there direct. Some of you still thinking it's direct, and that's the way to solve it. So good, Eunice. You apply the property as well. Okay, you multiply the 4 times 80, right, which is 320. But I have an observation here, little observation, is that we're gonna multiply those two. Okay, so we may show them like they are multiplying. It's not like they are dividing, right? It's like they are multiplying. I'm saying the x and the 20. That's all.
Okay, so instead of using like the line, I could have used the 2 dots then to show the ratio. So that way there's no confusion.
Okay. The ratio, you have to show it like it is, right? Like a fraction. But the property you need to use is multiply those numbers, the 80 and the 4.
Oh, okay.
And multiply the x and the 20. That's what the rule says. When they behave inverse way, not direct, okay, we may conclude the answer this way. As you can see, there he is. It's inverse proportion. It doesn't work directly. It's not that more pipes, more time. Doesn't have sense. Doesn't have any sense, right? Don't know if you see it. Try to fulfill a cup over your house over there with 2 things. I don't know. Tratemos de llenar una tacita pues con dos vasos llenos de agua. Se va a llenar más rápida a lo que la llenemos con una. Y si la llenamos con 3, se llena mucho más rápida a lo que la llenamos con una. Entonces, this is inverse, right? This is what the problem is about. You got it?
Yes.
Yes. Okay. That's so good. That's so good. Thank you. I appreciate a lot your participations. So there is the answer. By the way, your classmate did it. So good. And I think that with this ones, we conclude the topic of, with this one, we conclude the topic of the proportionality or of proportions. So then, any question about the proportions?
No.
So we may have 2 kind of situations, behaving directly, behaving inversely. Okay, if we're clear with the proportions, we are ready to start our next part of the topics today, which is talk about the sequences, okay? Breaks is like in 30 minutes, so we may try to focus in this part too because it's so important. Here, we will work formulas, which at the end is another element of the algebra. Because as we teach, we don't teach mathematics from 0. And that's why I cannot teach you mathematics from 0. Because I think you already know how to add, multiply, that you already know how to use this tool and everything. But if you need some help over there, you can make your questions, no problem. My point is next one. Algebra, it's trying to work for generalizations of these rules. I like when you say, well, all that I have to do to get 30% of a number is multiply it by 0.30. I like what Miss Cynthia said too when she said, all that you have to do is get the product of those numbers and then divide this product by 100. It's essentially the same idea. Okay. So it's pretty simple, and let's start now with the next part. Like I say, the sequences require that we, first of all, analyze where can we see it. Second of all, is the use of formulas, which is now the next part of the class. I think so. Essentially, one objective here will be this one, or one competence here will be this one, and is use formulas. Okay, so when we talk about mathematical sequences, we should see a little bit of the definition of this one. And essentially, is a kind of connection or relation between the natural numbers, the numbers we use to count, to the real numbers, the numbers we use. It can be decimals, it can be fraction, it can be whatever you want, okay? So number connects from one set to another, making mathematics relations. In algebra, we didn't say it. You say graphs when we talk about what is algebra. Some of you say graphs. Essentially, we can say relations, because at the end, the graphs, when we make the points and everything, we focus in the relation of some value with another value. This makes a point. And the points are ordered pairs. When we talk about mathematical sequences, those are connections of numbers that they are built as a set. Remember me, remind me something about set. What do we know about set of numbers? What do we know about set of numbers? Because this is essentially what we want to do. Build a set.
They are elements.
They have elements. Okay, I'm gonna write something here. Can we say that those elements I'm listing here, 2, 2, 5, 6, 7, 7, makes a set? Can we say that those makes a set?
You cannot repeat numbers, right?
Okay, thank you. There are little details that count at moments when we talk about mathematics, right? And one of these details is that, for example, I cannot repeat that 2 twice. So be careful with this. And yeah, in set of numbers, we may not see repetitions. But I think that sometimes, and this is something kind of confusing, some mathematics relation works with repetitions. Just that essentially, we don't repeat at all, okay? Like I'm saying, in this case, we will relate those natural numbers, 1, 2, 3, 4, 5, with numbers that makes a sequence or another collection of numbers, but they will behave like a pattern, okay? They will behave following a pattern. For example, I have the pattern of 3, 6, 9, 12. Don't know if you can tell me what is the next one?
15.
It's 15. Because essentially I have here the tables of 3, right? 1 times 3 is 3, 1 times 2 is 6, 3 times 3, sorry, 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3, okay, there you go. You got it. So essentially we do this, we teach sequences. Just that we don't teach it always like that, right? That's a little observation too, and we don't teach it in the way of sequences. But we need to understand the relations we can make with numbers. And one important relations, or some important relations we can make, not just with numbers, are the sequences. So in sequences, we may understand that if we start in natural numbers and then we go to real numbers, okay, I mean, we will relate every natural number with a real number, making that connection or that relation. We may focus that natural numbers define numbers we use to count, but define the position or the positional system or the cardinal system as we know it. For example, we have first, second, third, fourth, and so on. And this is useful at moment to analyze mathematical sequences. And essentially, this is what we want to know. For example, I have a little example over here. I think last time we tried it. What about next sequence? I think you can help me to make it. If this one starts with 2, then it goes with 4, then it go with 6, then it go with 8. I don't know if you can tell me what are the next ones.
10,
10, 12,
What,
14, 16.
what numbers are these ones?
even numbers.
They are
Even numbers.
even numbers. So this sequence receives a name. That's other thing. Some sequence are already defined and they receive a name. For example, this is the sequence of even numbers. And how can we get the sequence of even numbers? If I know this is my first element, this is my second element, this is my third element, the fourth, fifth, sixth, seventh, and eighth, because here goes the important relation. Look, I'm going from natural numbers, well, in this case, to another natural numbers, but at the end, if they are natural numbers, they are real. But essentially, I'm going like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I can go so on, but they are related with the 1 with the 2, the 2 with the 4, the 3 with the 6, the 4 with the 8, and the 5 with the 10, and so on. What is the relationship they are following? Don't know if you see, they make that sequence, and we can summarize that sequence algebraically, which is at the end what we want to. Is there one way to write all of them in a simple way? No. Last time we saw it. In last class we saw it, I think. I mean, is there any relationship like the one when you answer 15, for example, I told you it was the table of 3. Is there any relationship similar to this one here? With the 1, the 2, the 2, the 4, the 3, the 6, the 4, the 8, the 5, the 10? Is there any relation?
Isn't it we have to find the common number between them?
And in
Or
this,
that they are multiples of 2.
excellent. It's simple like that. We may find a common number, or if they are following a relationship that we already know. For example, multiply times 2. Exactly. And I can say, in general, of course, we will study how to do this. In general, we can write all those numbers just like 2 times n. Of course, n are the natural numbers. Sorry, not the real. The natural numbers. The numbers we use to count. This is the way to represent natural numbers, right? So natural numbers like 1, 2, 3, 4, 5, and so on. But we say we're going to include the 0, right? So all these ones counts like natural numbers. 1, 2, 1 is with 2, 2 is with 4, because if I multiply 1 times 2, I get 2. If I multiply 2 times 2, I get 4. If I multiply 3 times 2, I get 6. Don't know if you see now how the relationship goes. Yes? An important question to you. Maybe this will be outside of the class, but an important question to you. Because in New York, and I think here in our country, when the pandemic was starting, many people has a problem, the same problem that I think you will have right now. What do you think about 0? Is it even or is it odd number?
I'd say it's an even number.
Why?
I don't know why, but 10 has a 0 and it's an even number.
Okay, what a good analysis you did. Yes. Well, let me tell you that, yeah, 10 is an even number and 0 is an even number too. Don't know if you remember when we were starting the pandemic that just some cars, if you have a car, can go outside. If you have an even number at the end or an odd number at the end. It was related with this. Ana Maria.
Yes, Marcela is not having energy, and when they do not have energy, obviously they do not have internet. so she will not be able to be in the class right now.
Marcela.
Yes, Marcela.
Marcela.
Yes, I think.
Okay, thank you.
Mhm.
She can ask for una recarga, I don't know, maybe.
She was, is that she lives in a place that, lo voy a decir en español, es un lugar donde es bien rural, donde, como en una montañita podría decir, no sé, pero es un lugar donde no es como que cuentan con el internet fabuloso que nosotros contamos. Y
Okay.
ella tiene sus datos y tiene saldo y todo, pero no le funcionan los datos en ese lugar. Entonces, por eso.
Ok, muy bien. Bueno, pero igual que se
Y yo le
justifique con
dije
la
que
link,
cuando
¿verdad?
le
Recuerden
viniera
que
el internet que hablara con ella, porque sí, no se puede.
sí, yo honestamente ya esas cositas, está bien que me las reporten, pero quien da el visto bueno y todo es la link al final. Bien, so here we have one example. We can create another example. What about the shapes you can make with triangles? Or the size that the sides that one shape can have with the amount of triangles you work with. For example, if I have one triangle, how many sides does it have?
3.
Excellent. If I have one triangle, then we will see the sides, and it's 3. If I have two triangles trying to connect those triangles each other's, yes, as you can see here, I have the two triangles. How many sides do I have? The inner part, this one doesn't count like a side, okay? Be careful.
So 4.
So 4. If I have 3 triangles, then we'll try to connect them. How many sides does this shape has? 1, 2, 3, 4, 5. 6, right? So just following the sequence and without doing the drawing, what will happen with 4 triangles, do you think? Is it 6 over here? 1, 2, 3. Let's see. 1, 2, 3, 4, 5, 6. You're right. If I'm continue over there, how many sides do we need to make this?
8 sides.
8 sides. If I have 5 triangles, so then I think we will have 10, right? Okay. So that's like the main idea, and this is what we want to study. Essentially, there is a ways to summarize the behavior of these numbers. It is not complicated, but we can make sequences with many things. Of course, in mathematics, the topic of sequence is very important. Let's see it with one possible real situation. And with this one, then I think we can start talking about the first kind of sequences we may study. Suppose that you are organizing a party, okay? And you have an amount of table, and for each table, you will add an amount of chairs. In this case, in this table, you can fit 4 chairs. But if you have 2 tables together, if I have just one, but if I have 2 tables together, how many chairs will I need?
6.
6 chairs. We'll need 1, 2, 3, 4, 5, 6. So here we need 4, here we need 6. As I need one more table, how many more chairs will I need?
8.
I will need 8 in this case. So how many more?
2 more. Then
2 more. So without doing the drawing, I think you can tell me now How many shares will I need with 4 tables?
10.
10, and so on, right? So at the end, and again, there is a way to describe these mathematically. And those relations we are doing right now makes the idea of sequences. Sequences can behave in many different ways, but there are two that will
Following a
call our
pattern,
attention.
right? When we are
Excuse me?
following a pattern.
Exactly. And patterns in mathematics is, well, there is an area of mathematics that's focused just into the study of patterns. And it's so important because at the end, they have many uses. It doesn't look like it's useful, but at the end, they have many uses. I was saying long time ago, the interest, the calculus of the interest was based on the geometric sequence. But let's start first with the arithmetic sequence. What is arithmetic sequence? Well, we are clear what is a sequence, so now let's classify them. Again, like I was saying, we can classify sequences like arithmetic, geometric, but we may focus in those. There are other kind of weird sequences that exist in real life too. If we have time, I will show you one video about the conclusion of the last class, like for example, why we have to write the numbers as we normally do, why we don't why we don't write the numbers like Mayan numbers, or why we don't write the numbers like Roman numbers, for example, because we use those symbols today. So arithmetic sequence is a sequence where the elements are following a pattern given by the addition or subtraction of a number. And this stays every time. This addition stays every time. For example, here you told me there is like +2 every time in that exercise of the tables and shares. There is +2 every time. So this is something that's telling us we are having a arithmetic sequence. And this difference or this addition will stay every time between two numbers. Here's an example. And the way to represent a sequence is using that notation, okay? So a sub n practically is the way to tell or to talk about a sequence. This is a sequence notation. Okay, here we go. If I have the numbers 1, 5, 9, 13, 17, 21, 25, can you tell me what are the next numbers or what is the next value? Don't tell me, show it over there. You can write it, no problem.
I think it's 29, but I can't write it because I don't have the Jamboard since I'm from my phone.
Okay, Stephanie.
Yes.
Your number?
20.
What is the number?
My number 1.
Number 1.
Yeah.
Yes.
And I said it's 29.
You say it's 29, not 19. So
Yes.
20. So Stephanie. That's so good. I'm watching over there, and Misha, you're right. Yes, and it's 29, the next one, right? Oh, here it is. So good. So good. You got it. It's not complicated, I think so, to understand how these ones behave. If I ask you what will be the next one, can you tell me what is it?
33.
33, because you already see something happens between the numbers. And this that's happening between the numbers happens every time. So what is the common difference they have? Can you answer here?
They have 4 numbers in
between them.
Mhm.
Okay, should write this. They have 4 numbers between them or 4 units between them. Excellent. Write it like there's a 4 or there's 4 units between them. This again, Stephanie. number 1. Don't know if I'm writing your name correctly, Stephanie.
No, it's Stephanie, like Stephanie.
Stephanie. Like this. Like that.
Yes, like that.
Okay, sorry that I wrote it wrong here. Sorry.
No worries.
But there you are. There's your participation. There is a 4 between them. There is a common difference between them. That's all good. That's all good. I like it. Appreciate a lot your participation in here. Okay? Okay, there you go. So let's leave it here. That's so good, Carolina. There you participate. And that's so good, Catherine, too. You participate. And let's see now and answer the next question. It says, how could you determine the 20th element? When I'm saying the 20th element, focusing next. This is my first, second, third, fourth, fifth, sixth, seventh. Right now, you told me the 8th element. How can I get the 20th? The number 20. How can you get it? Can somebody tell me what it will be? The 20th element over there, or the 20th element? And how can we get it?
Counting by 20.
Counting 20, but in this case, my counting will require something, right? Because, I mean, the first number is 1. The second number is 5. The third number of the sequence is 9. How can I get the number 20? The one you told me right now, 29, is the number 8th of the list. How can I get the number 20th of the list?
We need to change the units. We need to change to 5 units in order to get 20. Right? If it goes after 5, then we have 10, then counting by 5s.
Okay, so what will be the 20th element?
1, 5, 10, 15, 20.
No.
It would be 77.
What? Okay, 77. And how do you get that 77? Who speaks? Sorry, I couldn't see.
Eunice.
Eunice. Why 77?
I don't know if it's right the way I did it, but it worked. So what I did was multiply. For example, I used 9, that it's in position number 3. I used it as an example, so I multiplied 3 times 4 because there's 4 units between each number. So then I multiplied 20 times 4, and I subtracted 3 because 3 times 4 equals 12, but for it to give me 9, I had to take away 3.
Wow.
I know it's complicated, but it worked.
No, it's not complicated. It's essentially what we have to do, or what we will do with this topic. Honestly, yes. Look, well, I'm going to tell you the history of these problems in Spanish. Este tipo de problemas en matemáticas son muy utilizados para describir fenómenos de la naturaleza. Más adelante yo les quiero presentar un videito que habla sobre, o le puedo dejar ahí un videito que habla sobre una secuencia muy famosa que es la Fibonacci, por ejemplo. La secuencia de Fibonacci describe muchas cosas de la naturaleza, como el número de pétalos que tiene una flor, o la cantidad de ramas que van creciendo en un árbol, etc. Pero lo que acaba de hacer Eunice fue algo que hizo un matemático muy famoso muchísimo tiempo atrás. ¿Han escuchado alguna vez sobre Gauss, el príncipe de las matemáticas? ¿No? Bueno, pues déjenme decirle que más o menos algo así como lo que concluyó la compañera ahorita hizo él. Le pusieron una tarea de averiguar cuál era la suma de los primeros 100 números, o sea, del 1 al 100. Muchos niños estaban, ¿verdad? 1 más 2 es 3, 2 más... y así siguieron, ¿verdad? Y siguieron sumando número por número hasta llegar al 100. Claro, eso es una tarea que tomaría bastante tiempo, ¿no? Ahora, lo que hizo Gauss fue que creó un sistema, así como el que acaba de crear la compañera Eunice, para resolverlo de manera rápida. Y de hecho la respuesta está ahí. No sé si ven ahí en azulito, I wrote it like 4n minus 3, which is essentially what you discover or what you say. You multiply 4 times the 3, which gives you 12. And this is to get the third element you have over there in the list. Okay? Essentially, this is what Gauss did. He discovered this rule, this kind of formula, which at the end summarize any element of this one. So the element is 77. The way to get it is this one. So as I said, we may focus into get any element using this formula. Okay, we cannot lose this formula over here. This is so important. For the exercises, this is so important, and this is what I want to teach you today, how to get it. Honestly, it's not complicated. This is the rule of the sequence. For example, tell me any number that you want to know of the sequence, any position of the sequence that you want to know. For example, the fourth one. When n is equal to 4, then I will have 4 times 4 minus 3. Question to you, which is the fourth element in here?
13.
13 is my fourth element, right? So check over there if 4 times 4 minus 3 gives you 13, because it gives you 13.
Yes.
Okay? So this is, in general, the way to write any element. Like in the table of 2, 2 times n will be the way to write any number. So this is what we will study today. How to generalize a sequence, how to get a sequence rule, and this is based on formula. So the job of this topic is not complicated, but I think it's already time for our break, and I'm always respecting those moments. So it's 10 o'clock practically, so I will see you in 30 minutes. Go for that coffee, go for that little lunch, because then we come back with these arithmetic sequences. Okay? So see you in 30 minutes.
Professor, I have a question before we go.
Thank you.
Tell me.
Remember my group, like we split into 2? So my group will be the last one now, group number 5, I think.
We will not work 5 groups. You still be working group number 2. Okay, just that maybe I will work
Separately.
some minutes with you and some minutes with the other group.
Okay.
Yes? Okay. No more questions? No? Okay, so see you in 30 minutes.